Welcome to class. Today we are going to discuss about the similar triangles. Our topic is similar triangles. Here we are having the words similar and the triangles. Before going to know about the similar, already we learned about the triangles. Triangle is nothing but a polygon. Polygon is nothing but say closed figure. Closed figure means we have types. How can we take? If we are taking one circle, it is also a closed figure. If we are taking triangle, also a closed figure. If we are taking quadrilateral, also a closed figure. But here we should not consider circle as a closed figure in this case. So polygons we are discussing. Polygons is nothing but made up of line segments, minimum 3 or more than 3 line segments. So in this case we can discuss about the triangles. It is a closed figure made up of 3 line segments. It has vertices, sides, angles and types of triangles we have discussed in the previous classes. But here we are going to discuss about the similar. So before going to know about the similar, we have to know about the congruency. Already we learned about the congruency. Congruency means whenever we are taking two geometrical figures that should be same in shape and size. We know about the shape and the size, both are same, we can say congruency. Here also we are using the congruency figures with the symbol. If we are taking triangle ABC is congruent to triangle DEF, we are choosing with the symbol. This is called congruency. Here we are having the symbol. This is the denoted as congruency. We know about this symbol. It is equal. Means whenever we are taking two geometrical figures, both are equal in the shape and size, then we are choosing this one as with the symbol of congruency. If not, both the triangles are the geometrical figures, we can say not congruency. By using this symbol, we can say not congruency, not congruent. So here we need to know about the similarity. Similarity means here we are taking group of apples. In the group of apples, all apples are look like same, but in the shape and size we have difference. But we can say the group of apples are similar. In toys also we can define similar. Both the shape should be same but size not equal. These type of things we can discuss about the similarity. Coming to the geometrical figures. Geometrical figures, we are taking here triangle. Here also I am taking triangle. Here also I am taking triangle. Here I am taking ABC, XYZ and PQR. I am saying these three geometrical figures or triangles are similar. How I am saying? Using the symbol triangle ABC is similar to triangle XYZ is similar to PQR. So here we are taking the all triangles are similar. Why I am saying that look like all are triangles, but the shape may be equal or smaller the comparingly corresponding sides or angles. So although you can say these are the similarities. Here we want to know about the similar triangles. Already I discussed about the similarity and triangles types whatever we are having. So how can we derive the similar triangles? Similarity of triangles. See, whenever we are taking two triangles, I am taking triangle ABC and triangle PQR. Here, whenever we are taking two triangles, the triangles should be having the similar angles. Corresponding angles are similar. We are taking here angle A, angle B, angle C. Here also we are taking angle P, angle Q, angle R. These two triangles having the similar corresponding angles, then the corresponding sides also similar. How can we derive this? So let us consider how can we derive means we can take, let us consider similarity of triangles. I am taking here the triangle here. I am taking A, B, C and C, D, E, taking C as common for the two triangles. Here A angle, D angle both are equal. Here angle B and angle E are equal. Angle C is common for the both. Here vertex is common. Then we are taking the angles are equal. So how can we take this? We know. So we can take angle A is equal to angle D. Already I took here, and angle B is equal to angle E and angle C is equal to angle C. These are the angles we are taking. And also can take the sides. As I said, corresponding angles are equal. At the same time, the corresponding sides are also equal. How can I take DE by AB is equal to EC by BC is equal to DC by AC. So we can take is equal to K. K is the scale factor we can take. Scale factor. How can we take this both the triangles? As by taking triangle ABC is similar to triangle CDE. CDE we can choose by using the symbol similarity. Here we need to know one point here about the K. If K, already I said about the scale factor, if K value is greater than 1, how the angles? If K value is smaller than 1, if K value is equal to 0. How can we take in these three cases? If the K value is greater than the 1, by taking the scale factor, we have enlarged figure will get. The K value is greater than 1, we will get the enlarged figures, means bigger we are saying in other words. And if the K is smaller than 1, we have reduced figure, means smaller. If the K value is equal, we have similar figures. We are taking figures we are taking. This is the way we can derive the similarity of the triangles. One more point we can say here, that is, if two congruent figures are similar, but two similar figures need not be congruent. Congruent we can say is the one of the point in our similarity in the triangles. How can we take? I am taking one example. Here I am taking say square. Taking all sides are equal, and here angles also equal, and again I am taking here is a rectangle. Opposite sides are equal. Rectangle. In the rectangle, I am taking ABCD and I am taking here square as ABCD and I am taking rectangle as PQRS. So how can we say this one? Here angle A is equal to angle B, because in quadrilateral we are defining here square and rectangle. All angles of the square and rectangles are 90 degrees. We can say angle P and angle B is equal to angle Q, and angle C is equal to angle S, angle D is equal to angle R. We can take in the all the cases both the figures we are having the angles are equal, but in the shape they are not equal, they are not look like same. So maybe the area should be equal, same. In this case we can say congruent figures, not we are defining here equal. Here I said if two congruent figures are similar, but two similar figures need not be congruent. So we can say similars but not congruent. Some cases we are having both are congruent, maybe they are not similar. Coming to the basic proportionality theorem. Or Thales theorem, we can say. Basic proportionality theorem or Thales theorem, both are same. How can we take the basic proportionality theorem? If a line drawn parallel to one side of a triangle, another side of a triangle intersecting the other two sides at distinct points, then the other two sides are divided into same ratio. This is the basic proportionality theorem. How can we derive this one? I am taking here one triangle. A, B, C is a triangle. I am taking one point here, this is D and E. I am joining these two points D and E. Then these two values are same in size or length. Here how can we take in triangle ABC? Here we can say DE is parallel to BC side. Then we can derive this one. AD by DB is equal to AE by PC. We can say this is the basic proportionality theorem. Now we can prove the basic proportionality theorem. How? See, I am giving the proof. I am taking triangle here ABC and taking points here D and E, and I am joining these 2 points, and this is the parallel to the BC, base of the triangle. I am joining the points. I am drawing the D2 opposite side E, and one more line I am joining here from E to opposite side of AD. I am taking the intersecting or the perpendicular points on AE and AD as M and N. So again I am joining the B and E. So I am taking this diagram to prove the basic proportionality theorem. See, in the triangle, area of triangle AE, we know the general formula of into base we are taking ADE, where we are having ADE. In this triangle we are taking base is AD, and the perpendicular means here we are drawn, this is called height EN or NE. We are taking, this is the area of the triangle AD. Again I am taking area of triangle BDE, that is nothing but of into BD is the base, and EN or NE are the height of the triangle. So using that two situations, area of the triangle AD and BDE, we can take area of triangle ADE by area of triangle BDE is equal to what we are having, area of into AD into NE by of into BD into EN or NE, both are same. So here I am cancelling the values of will be cancelled, EN, NE, both are same. Then we are having the values AD by BD. Take this one as one equation. Again I am taking Again, I am taking area of triangle ADE is equal half into, so here AE into DM. In the triangle ADE I am taking, again this is the base I am using AE, and this is the DM is the height. Again I am taking area of triangle CDE of into, I am taking CE into MD or DM, both are same. So here I am taking the values the proportional, then means ratio area of triangle ADE by area of triangle CDE is equal of into AE into DM by of into CE into MD or DM, both are same. We can take by cancellation, we will get the values here. AM DM will be cancelled, half of will be cancelled. Then we are having the value AE by CE. We are taking this one as second equation. So from the 1 and 2 equation, we can say from 1 and 2 equations, we can say both the triangles area of triangle BDE is similar to area of triangle CDE. Take this one as third equation. So how can we say the basic proportionality theorem? By using these three conditions I will show now. So from the 1, 2 and 3 equations I am deriving the AD by BD or DB, both are same, equal to AE by EC. This is the basic proportionality theorem we can prove. Hence we can write this one as hence proved Taylor's theorem also. Taylor's or basic proportionality theorem. In this manner we can define and we can derive the basic proportionality theorem. Now we are going to discuss about the criteria of similar triangles. Here we are having three types. One is the angle criteria. First one, how can we derive in the triangles? I am taking here ABC and triangle taking DEF. I am taking here. So in the AAA criteria, we are having angles are same. By using the angles, we can say the corresponding sides are equal. How? See, I am taking angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. By using this condition, we can take the sides AB is equal to DE and BC side equal to EF. Then we are having AC side is equal to, so we can say both the triangles are similar. So triangle ABC is similar to triangle DEF. Coming to the next topic, SSS criteria. So here we are taking SSS criteria, means side. By using the sides, we can see the angles are equal. Then only it is the similar triangles. So in the triangle, I am taking here angle A, angle D, angle B, angle E, angle F, angle C. See how I am taking. Already we have in the angle criteria. AB by DE is equal to BC by EF is equal to AC by DF. We are having these the sides. By using sides, we can say angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. By using this condition, we can say triangle ABC is similar to triangle DEF. Now the third point we are having here, side criteria. How can we take? Whenever we are having the triangle, the angle should be coming in the middle of the two sides. This is the common meaning. How can we take this one? So I am taking here triangle ABC and triangle DEF. I am taking angles here A and D. This is the side we are having here. We are having the sides, second side. So by using this angle A is equal to angle D, then we are having AB is equal to DE and AC is equal to, we are having CA or AC. So with that condition we can say both the triangles here ABC is similar to triangle DEF. Coming to the next topic, we are having Pythagorean theorem. What is the meaning of Pythagorean theorem? Generally, everyone knows about the Pythagorean theorem. Squares of the hypotenuse is equal to the sum of the squares of the other two sides. Exactly, we are using that condition. It is nothing but Pythagorean theorem. See, how can we take here? One triangle I am taking here. So, this is the 90 degrees angle I am deriving here. Then I am taking A, B, C here. Then it is called hypotenuse here. And this is the height or side. Height or side here. Then this is the base or side. We can take these two the sides are height and base, and this is the fixed hypotenuse. Why we are saying it is a hypotenuse means we are having the right angle, means here 90 degrees angle. That angle opposite side always should be hypotenuse in the right angle triangle. Already given angle A is equal to 90 degrees here, and we know that hypotenuse BC square is equal to AC square plus AB square. This is the Pythagorean theorem we are having. Coming to the one more topic in the similarity of triangles or similar triangles in our topic, Baudayan theorem. Baudayan theorem. So, what is the meaning of Baudayan theorem? It is nothing but just like our Pythagorean theorem, but Baudayan derived this one before Christ 800. He derived one more formula by using the rectangle. We are taking AB, CD, then this is the diagonal. Okay, so how can we derive this one, Baudayan theorem? Whenever we are having the diagonal, if we are increasing the diagonal, automatically the size should be increased, then the area should be same. In this manner, he derived the Pythagorean proof. Here we are taking area of diagonal AC. When we are proceeding, means here produced with this one, we are extending, produced with this one, AC diagonal is equal to AC into CA or AC, both are same. Then we can take this one as AC square. This is the hypotenuse we are using. Area of produced side BC, then BC into BC is nothing but BC square, and area of produced side, what we are having, that AC or BD. Whenever we are taking here, this is also a diagonal. AC we produced, then automatically that BC should be produced. Automatically we can say the AB also produced, AB into AB, then we can take AB square. How can we derive? Here in the triangle ABC, we are having AC is the hypotenuse, AC square is equal, and BC square plus AB square. In this manner, Baudayan derived the Pythagorean theorem. Here we are having the point, the ratio of two areas are similar in triangles equal to the ratio of the squares of their corresponding sides. How can we take? So here we are taking area of triangle ABC ratio. We are taking area of triangle ABC and area of triangle we are taking DF. Then the ratio when it is increased, squaring, the value will be automatically increased the sides. Then we can take this one as AB square by DE square is equal to BC square by EF square is equal to CA square is equal to, we are having FD square. This is the condition we are using here. When the areas ratio should be increased, the sides square should be increased. Both should be equal. Now I am here going to give some important points here. So about the statement for the sentences. For sentences, how can we give the statement? The first one here we are having, if a sentence is yes or no, such sentences are called simple statement. Next one, if the statement or sentence is combining both means here we are having two or more simple statements, then it is called compound statement. Coming to the third statement, a compound statement we are having, then it is having if then. Compound is we are having if and then. Such statements or sentences are called conditional, or we can say it is a implication. We are having compound or implication statements. Here we are having simple statements, and statement should be two or more, then we can say compound statement. Then compound statement should be having if then, are called implication or conditional statements. Coming to the next one and the last one, a statement obtained by obtained by modifying the statement by not is called negation. You can take this one as negation. These are the important sentences or statements we are having in this chapter.